The problem is from GATE 2018 mathematics paper, question number 2. The problem is, let f from C to C, the set of all complex numbers, be an entire function with f of 0 equal to 1, f of 1 equal to 2, and f dash of 0 equal to 0. If there exists m greater than 0 such that absolute value of f double dash of z is less than or equal to m for all z belongs to C, then f of 2 equal to, it is asked to calculate f of 2. The four options given are option A 2, option B 5, option C 2 plus 5i, option D 5 plus 2i. So the NPTEL reference to solve this problem is module 3 lecture 7 of complex analysis, and the title of this talk is, this lecture is Cauchy's integral formula and its consequences by Dr. P.A.S. Srikrishna. He is from Department of Mathematics, IIT Guwahati. Even you can watch this lecture using this YouTube link. So now coming to the solution, it is just given that f is from C to C, comma, f of 0 equal to 0, f of 1 equal to 2, and f dash of 0 equal to 0, I think. F of 0 equal to 1. And it is given extra condition that there exists m greater than 0 such that modulus of f double dash of z is less than or equal to m for all z belongs to C. So now we solve this theorem using a famous theorem, that is Liouville's theorem. By just looking at the theorem statement, one should observe this condition that f double dash of z is less than or equal to m. This is the main condition depending on which we solve the whole problem. So we have the Liouville's theorem, which states that it tells us that a single line statement, a bounded entire function is constant. To solve this problem by using this theorem, one should know 2 points. That point 1, if f is entire, implies f dash comma f double dash comma f triple dash and so on, f any nth derivative is are also entire. And the second point is, if f is entire, and there exists some positive constant such that f of z is less than or equal to m, then we have f of z equal to a constant function. This is nothing but the Liouville's theorem. So now based on these 2 points, we solve the problem. So since it is given that f is entire, and by the first point here we can say f double dash, f triple dash, and f any nth derivative of f is also entire. So we have, since f is entire, f double dash is also entire. Entire in the sense entire function. And since it is given, since it is given that modulus of f double dash of z is less than or equal to m for all z in C. So by Liouville's theorem we have how f double dash, since it is given that f double dash is bounded, f double dash of z is equal to some constant for some a in C. Since it is given that f double dash is bounded, not f, so we have f double dash is some constant. If suppose there is it is given of f of z is bounded, then we can directly say f of z is equal to a. But since here it is given f double s is bounded and it is given that f is entire, so we can say f double s is also entire and hence it is bounded. And sorry, it is constant. So now we have it is given some more extra conditions that okay. Firstly, let me write this. So since we have f double dash of z equal to a, from this we can easily see that f dash of z equal to az plus b for some b in C, which can be seen easily by the integration. And similarly, f double dash of z can be written as a z square plus bz plus c for some b comma c belongs to C, the set of all complex numbers. So now if we look at this, sorry, here it is f of z. So now if we look at the function, entire function f of z, we can see there exist three unknown constant in this polynomial. That's why it is given three independent conditions with which we can calculate these three independent unknown constants particularly. So now for these, from this we can say f of z is nothing but a polynomial of degree 2, but with the coefficients a, b and c. So now our question is, what are the values of a, b and c? For this, by using these three given conditions, we calculate the values of a, b, c. So for that, since f of 0 equal to 1, f of 1 equal to 2, and f dash of 0 equal to 0. So we have from the function f dash of z equal to 0, we have f dash of 0 nothing but b that equal to 0. So we trivially got the value of b as 0. And by the condition f of 0 equal to 1, we have f of 0 is nothing but c that is equal to 1. So trivially we got the values of b and c, yeah, these two. So now for the value of a, we substitute f of 1 equal to 2. F of 1 is nothing but, since we have already got the values of b and c, so I can substitute the values of b and c as it is. So then we get a plus c as 1 equal to, by the given condition, 2. So from this I can say a equal to minus 1. So the entire function f of z is, so f of z is equal to minus z square b is 0 and since c is equal to 1, so plus 1. Sorry, since a plus 1 equal to 2, we have a is equal to 1 only. So from this we have f of z equal to z square plus 1. This is our entire function which satisfies the given all conditions, these three conditions. And of course we can find the m for which f double dash of z is less than or equal to m. and of course we don't need, but just for a clarification we can see f double s of z is nothing but a, and we got the value of a as 1 here. So we can take here, we can take the value of m equal to 1. Of course we don't need it, but just for a clarification you can see this function satisfies all the given conditions. So now from this we can see what it is asked to calculate is the value of f of 2. So from this we can straightly calculate f of 2, that is equal to 2 square plus 1, that is nothing but 5. Therefore f of 2 equal to 5. So the answer is B. Thank you.